Hello, this is going to be another programming video and I hope that it goes well because there's something really cool that I want to be able to show you. I finally figured out how direct pixel access works in ImageMagick, and it's a little bit complicated, but you'll probably understand it by the time I'm done with this video as well. Okay, so basically here's how it's going to work. I'm going to show you what's on my screen, make sure it's going right. It appears to be. Okay, so here's what we have. I have my source code here. I'm going to show you my main function of my program here. I have tons of code commented out that's not being used. I tend to write functions and then I just call them from the main function. So first you see that the width and height of my image here, which tends to, it's actually a global it's a global variables for the width and height, pretty much because of the fact that I have just been doing one image at a time, which is interesting because technically this program could be modified to do multiple different images, but that's just not the way I've done it so far. I'm just in the learning process. So, but here's what's interesting is I have the direct pixel test function that it's calling, and it's calling the image, named image, by reference. Okay, and here is my direct pixel test function. And some of this code has been copy pasted from the website. And what I'm going to do is I'm going to run it and prove that it works for what it's intended to do. Remove a few extra empty lines. Okay, so we're going to compile and run this. I have my command there. So it's going to compile and then it's going to run it. And when it runs, you're going to see a message. Notice it says size of quantum equals 2. And that's because apparently the size of each pixel is 2 bytes. It's a 16-bit integer value, and that's what I discovered. It's a little bit weird, but here's basically how it works. Okay, so the thing is, I have GIMP open here, and I'm going to revert the image just to make sure it's up to date. And here's what you see. You see 2 pixels. We see a white pixel here at position X4 and Y2, and that corresponds to what's in the source code here. X equals 4 and Y equals 2. I set those integer variables to those numbers. And then it gets a pointer to that specific pixel using this complex formula that I've been using for years. And it works precisely because of the fact that there are four parts of a color. There's the red, green, blue, and alpha. There's 4 parts. So you have to multiply the X by 4 and the Y by 4. And you also have to multiply the width, because basically it's using the width of the image. Like each row is width of size, basically. So you multiply by that, but it works. And so that's why we have white, because blue, green, red, and alpha are all set to all Fs, basically. And that's where we get white. The next one is X is 8 and Y is 4. And let's look back at our image. This other pixel, this cyan pixel, X is 8 and Y is 4. So I have proven that my program actually works at writing to the exact pixels. So we're writing to pixel memory here. Well, sort of. It's a little bit complicated. The API sort of defines it. But basically, here's how it's working. So first, there's comments here, and these comments were in the original code that I copied and pasted from the website. But basically, it gets a pixel's view of that image. And then, basically, we have a quantum pointer, and we typecast it to that type, this view that we get. So we get this range. Basically, starting at 0, 0, the top left, to the image columns, which is actually the width, and the image rows, which is the same as the height. And of course, you know, I sort of interchangeably use my width and height variables and this. I'm going to eventually make it consistent, I think. But basically, given by setting the x and y values, we can then do a formula. Now, notice there's a slight difference. There's two syntaxes here. And I like them both. I'm going to leave them both in here. This is the one where you have set the pointer to this. This is one way of doing it. The other way is to reference it as if it's an array, but then get the address of that element of the array. And I think this second one looks better than the first. The first one looks messier, but both are perfectly valid. So now let's change the colors up a bit. Now, let's say that I change this this green to all zeros, and then we're gonna change. Let's see. Let's change this. Hey, I know. Yeah, we're gonna change this green over here to all zeros. So then, if I rerun the program, it takes a little bit of time to compile and rerun. But once it works, okay, there it is. So now we have to refresh the image. We just do revert. Okay, and then see, now we have magenta because we turned the green off from what was white. And now over here we have blue because we took out the green from the cyan. Now, there's just one final step to do to make this program complete. Notice it's not recognizing the alpha value. I have the alpha pixels here, and they're written as part of the 4-part quantum thing, whatever the quantum actually means. I don't know yet. I don't know what that word means, but I'll look that up later. So anyway, but notice that the type is set to true color type. But there are different types of images. Now, luckily, I have the documentation here. So, okay, now I want to go down to the type function. And there should be an alphabetical order. So, let's see, where is the type? Okay, I'm trying to find where the type is, because I know that there are different types. Let's see. Yeah, so it shows that there is a type function. But let's see here. Where is the type mentioned? Let's see here. Sorry, I'm trying to figure out where this is. Let's see, true color. Yeah, see, there's the true color type, but I'm trying to find out. Okay, I'm going to have to go back somewhere in the documentation. Let's see, what's this thing? Color map. Okay, I'm gonna go back a directory to the documentation. There's so many different files here. Wait a minute. I'm trying to get back to the main page here, because there is a page that lists all the different classes. Okay, let's see, where are we? Okay, detailed documentation. Okay, this is the one. Okay, so there's different types of images. I'm trying to figure this out. Perhaps the color class will give me information. Let's see. Now this class is all about the color. Yeah, it tries to explain about quantums. I've read it before but never understood it. And I'm trying to figure out the image type. Yeah, it's really weird when you see. Okay, yeah, it doesn't appear to be on that page. That's very weird. See, this here is the page where I copied my code from. Now, this has a lot of code that I did not copy paste. Where is the... Okay, I know it's in there somewhere. I know that it's in this API documentation somewhere. Now, where is it? Oh, this is frustrating. I thought it was going to be in this page. See, I made a mistake here. Yeah, because I'm trying to set the type of the image. Let's see, storage type. Construct a new image based on an array of pixels. Pixel storage type. Is this it? Oh, that's weird. Storage type. Storage type enumerates to specify the storage format of pixels in the source or destination pixel array. Oh, they have all these different types of... Oh, how weird. I don't even know what this means. That's very weird. Let's see. True. Oh wait, here we are. Image type. Yeah, this is... Oh, this is from the enumerations page. How weird. Image type indicates the type classification of the image. Okay, so here's the true color type. That's the true color type. However, there is a one with opacity, and that's the one that has the alpha channel. Sorry, it took so long to find it. Okay, and I don't know if I'll be able to get back to this page next time, but okay, so here's the deal. Check this out. Matte. Okay, so if I go back to my source code and true color MATTE, and then if I recompile and run it, let's see if the code still works, and maybe it'll work even more accurately. Okay, now it compiled and ran successfully. So let's see here what we have. Interesting. It's still not exactly working as I expected. Huh. I'm not sure why this is happening. Because I would have thought that the true color... Yeah, that's just so weird. Did I do something wrong here? I thought that I saved it. Maybe I didn't save the file. It's kind of weird, because it should be recognizing the transparency, because at least I want to learn how to get it to work. I don't really care about opacity myself. It's not, let's see here. It's interesting that it's not even showing that. Well, you know what? That's just weird. Hey, I wonder what happens if I set it to some other strange value. What if I change it to the grayscale type? It'll probably screw it up. Who knows what it's actually going to do? It'll probably do something really weird, but we will find out. Nope, it apparently has no effect whatsoever. Well, in that case, you know what I'm going to do? I'm just going to set it up the way it was. Let's see here. For example, and that function is actually in more than one place. See, this is also shows a image type is true color type. This one is slightly different. It's very... I see. Now, Yeah, I'm curious, but anyway, I'm gonna change this code back to the true color type, just because that's the way it was at the beginning. And since it works and it lets me change the colors to whatever arbitrary thing I want. So now this function is entirely useless except for the fact that it taught me how to directly access the pixels. So this function is silly and only proves that I can access the pixel array directly. Okay. So that's the thing, is I suppose that's going to be the end of my video. And yeah, whatever. I hope some nerd out there enjoyed that. But as you can see, I've been programming for a while and I've been trying to get it to work. And so I can change the color of the pixels to whatever I want at certain places. Now there exist functions for doing that, but I'm trying to learn the low-level pixel access way because I actually have plans for another function I'm going to write. So we will see how it turns out. So anyway, that's all for now.